Good morning, everyone. Last week, I was giving you this paper just to make sure you guys are studying enough at home. If we have enough time later, we can discuss these papers. Otherwise, I'm sending you guys the marking scheme. Marking schemes are like very simple and it has everything you can understand in the marking scheme. Time to time, I'm going to do these exams at the class, or sometimes I'm giving you guys a paper to do at home just to make sure, because these are very, very simplest questions. But sometimes some questions are directly I'm adding from these past papers. Then you are maintaining exactly the past paper style. Anyway, so since we missed one single day that you guys are a little behind, anyway, today we're going to complete this unit 1 syllabus, and then we are, for the rest of the time, if we have enough time, we're going to do unit 1 tutorial, and next week, being freshly, we are starting second unit. Again, for the second unit, I'm providing you guys this notebook and toolbook. Alright, let's start today's one. Last week we started to talk about these periodic properties. Periodic properties are really important to go through to understand the rest of these lessons. This is not like that directly asking a lot of questions for the final exam. Because for the very first one, it was radius of atoms and ions. So downwards the group, electrons are entering to new energy levels and shielding effect is also increasing, so that radius is increasing. Along a period, nuclear charge increasing, electrons enter to one single energy level. You look so different today. Yeah. But that's good, that's good. So that along a period, nuclear interaction is increasing, so the electron cloud is squeezing, so that the size is decreasing. But still, since this electron cloud is diffused and you cannot determine exact boundaries, so that what we are doing is we take two nuclei and get their distance divided by 2. Internuclear distance divided by 2 is the radius. So that these internuclear distance coming from covalent bonding, that is covalent radius, metallic bonding, metallic radius, van der Waal bonding, van der Waal radius, and ionic bonding, ionic radius. So the last week at the class, we completed covalent, metallic, and van der Waals. Are we? Yeah. Today we're going to talk about this ionic radius. Ionic radius is here. We don't have any other option. We just consider as atoms are rigid. They have exact boundaries, so that we are measuring this radius. So for that, we're going to define or talk about cations, anions, and isoelectronic species. Okay, let's read this little part. Topic number 4, ionic radius. This can be defined as the effective distance from the nucleus of an ion up to which it exerts its influence on in cloud. Here we assume ions are spherical and in solid crystallized form. Copy this part. Come. We just started. Go through last lesson. Okay, so that we're going to talk about cations, anions, and isoelectronic species. What are cations? Are species. Are you not done? Okay. Huh? Okay, I'm waiting. Sajid? Yeah. It's okay. It's okay. Take your time. Let me read it again. This can be defined as the effective. What is the page number? Huh? It's 80. It's supposed to be 83. Yeah. This can be defined as the effective distance from the nucleus of an ion up to which it exerts its influence on electron cloud. Here we assume ions are spherical and in solid crystallized form. Okay, so then we're going to talk about the cations. What are cations? Yeah, positive ions are cations. How do they get positive? By losing electrons, giving electrons away. Then what happened to the electron proton count? Proton count is greater than electron number, so that now our amma එක බබෙක් මැරිච්ච අම්මා වගේ නේද? So what happened? Rest of kids are having more attention, more attraction. So the electron attraction to nucleus are increasing. So what happened then to the electron cloud? Squeezing in so that the radius decreases. See, so that lithium is having, normal lithium atom is having the radius of higher 152, but when it comes to lithium plus, it's way less than that. See, it's now 60 picometers. What is picometer? Yeah, this is 10 to the power minus 12. Nanometer. N rhyming, so it's easy, I guess. Minus 9, and then angstrom. 10 to the power minus 10. You just knew the word. We didn't do any calculations with that. Okay, so let's read this part. Radius of cation. Cations have, let's read it. Cations have positive charge. Therefore, number of protons is larger than number of electrons. Then, the effective nuclear charge increases. Then, electron cloud contracts since electron-electron repulsion decreases, and hence the attraction of the nucleus electrons increases. Therefore, radius decreases. Okay. Cations have positive charge. Therefore, number of electrons is larger than number of protons is larger than number of electrons. Then the effective nuclear charge increases. Then electron cloud contracts since electron-electron repulsion decreases, and hence the attraction of the nucleus on electrons increases. Therefore, radius decreases. Lithium 152, lithium plus 60 picometers. Okay, then it's opposite supposed to be go for anions. What are anions? Species gaining electrons so that they are having negative charge. Then what happened? Electron number is now greater, so that the nuclear electron attraction is less, because inside the nucleus less protons are there. So that attraction is decreasing, so the electron cloud can expand. These are actually marking scheme points. Did I tell you guys how I made my papers, made my books? Would you know I started this advanced level journey? Yeah, so that make sure that whenever you are memorizing, you guys have to memorize all these steps together. Like whenever you are writing questions to structured essay, you guys have to write everything here. Okay, let's read this. Radius of an ion. anions have negative charge. Therefore, number of electrons is larger than number of protons. Therefore, electron-electron repulsion is stronger than electron-nucleus attraction. Then, the electron cloud expands and radius increases. Okay, just a normal fluorine atom has this 64 picometer, but once it gains one single electron, see its radius is really high. Copy this part. Okay, this is from your resource book. Now tell me, there are two different colors. These are cations, red and green. Now tell me which one is for neutral atom. Red radius or green radius? Cations and neutral atom. Which one is for neutral? Big one. Because once you gain electrons, radius decreases. So that they are smaller size are the red ones. And then this is the opposite. This is again from your resource book. What happened here is, once you gain electron, size is expanding, so that the outer one is, whatever these blue circles are what? These are anions. And these inner green parts are normal neutral atom. Clear? Alright. So go through the resource book. These are from resource book. Okay, so this one, isoelectronic species. Before move there, I want you guys to fill that table. Fill that little table before talk about this topic. Radius, you don't know, keep it. You just need to fill protons and electrons. Raise your hand. Correct. Good. You guys are there. It's easy. See. Proton is the atomic number, so it's 6 for carbon. It has gained 4 electrons, so 6 plus 4 is supposed to be 10. Neutral, at neutral time, atomic number same as the protons. Neutral time, because this is neutral, number of electrons are still the same. But sodium is ion plus charge, number of proton is 11, so that this atomic number is 7, so that the number of proton is 11. But here it has lose 1 electron, so that the 11 minus 1, so number of electrons is supposed to be 10. Okay, so that this is the condition of isoelectronic species. Okay, if they have same number of electrons, any species, even negative, even positive, or even neutral, if the number of electrons are same, How could you explain this condition? Number of electrons are same. Then, which size is larger? It's the same thing. If it is cation, size is small. If it is anion, then size is large. Understood? Okay. So let's read this to the part. Topic number 3. Radius of isoelectronic species. Isoelectronic species are molecules or ions with same number of electrons. In isoelectronic species, the one which has the highest number of protons has the smallest radius. Okay, let's stop this. Isoelectronic species are molecules or ions with same number of electrons. In isoelectronic species, the one which has the highest number of protons has the smallest radius. Did you complete the radius? Right, Dad? Something's missing? Are you okay? Okay. And see, this one is again from your resource book. Okay, how many electrons are there in any of these? I mean, oxygen, atomic number 8 plus 2, it's supposed to be 10. Fluorine, atomic number 9, you have negative 1 charge here, so it's 10. This is anyway 10. This is 11, losing 1 electron, 10. 12 plus 2 minus 2 is 10. So 1 is to 2 is to 2p6. Now all are having 10 electrons. So that size is from minus higher to plus higher, size supposed to be decreasing. Okay, so the radius going down the group is increasing. Radius is increasing. So which ability increasing? Making of anions or making of cations? When the size is larger, what is easy? Taking electron is easy or removal of electrons is easy? Removal is easy because less nuclear charge. So are they making easily anions or cations? Cations. Going down the group, formation of or the ability of making of cations increasing. Along a period, what happened to the size? Decreasing. Because of that, nuclear attraction is high. So what is easy now? Cation or anion? Yeah, gaining of electrons are easy, formation of anions are high. So that is the second one. Ability to form cation and anion. Let's read. Along a period from left to right, radius decreases. Therefore, gaining of electrons is easier than removal of electrons. Then, ability to form anion gets increased and ability to form cation gets decreased. Downwards the group radius increases. Therefore, removal of electrons is easier than gaining. Then, the ability to form cation gets increased and ability to form anion gets decreased. Copy this, complete this. Topic number 2, ability to form cation and anion. Along a period from left to right, radius decreases. Therefore, gaining of electrons is easier than removal of electrons. Then, ability to form anion get increased and ability to form cation get decreased. Downwards a group, radius increases. Therefore, removal of electrons is easier than gaining. Then the ability to form cation get increased and ability to form anion get decreased. හරි. මේ next part එක ඔයගොල්ලෝ මේක ටිකක් මේ කරලා තියෙන part එක. What is oxidation? Yeah, well done. Oxidation is removal of electrons. Okay, by removing electron, okay, before that I would move on to this little thingy. So the next topic is oxidation number. Oxidation number is some sort of a value that you are gaining with respect to number of electrons you have. As an example, okay, for unit 3, we're going to do calculation. So we're going to go through all the rules for unit 3, not now. But one of the rule there is naturally existing elements are having zero oxidation number. Now tell me, what are the naturally existing elements? Okay, this environment, what do we have in atmosphere? Oxygen, nitrogen, even argon, all these are. Even iron, even aluminium, even sodium, atomic level, they were not done with electrons. They are having all their electrons. So their oxidation number considers as 0. Their oxidation number considered as 0. Now tell me, what kind of oxidation number sodium is taking? Because sodium is coming from which group? Group 1. Say no. Group 1. So that it is always losing one single electron. When you are losing electrons, what happened to your own charge? It's increasing. By what number? One single, because you are losing one single electron. So that the oxidation number of sodium plus become what? If this is sodium, then sodium plus is what? Plus 1. Understood? That's the oxidation number of oxygen. Now tell me, what would be the oxidation number of aluminium? Saji, aluminium is a metal. They never gain electrons. Metals never gain electrons. Aluminium is aluminium guys, no, we are aluminium products. Aluminium metal. So aluminium, what does it do? What is the group number? That's okay. Yeah, that's correct. 3. So they are losing how many electrons? 3 electrons. So what is the oxidation number? Plus 3. That's how. Let's say, what is the most common oxidation number, the one single oxidation number for magnesium? That's plus 2. Plus 2. If it is oxygen, minus 2. If it is chlorine, minus 1. If it is fluorine, now you get it. Okay, I'm going to suspend that topic there. You understood what I want to convince you. So that oxidation definitely means losing electrons, so that the increasing of oxidation number. From whatever the existing level, if it is increasing or going to the plus, that is increasing. But you guys know oxidation is also removal of electrons. So that the reduction is gaining of electrons. Those two you done for all of us. Alright. So අපි ගමු හරි එකක් ක්ලීන් කරන්න. ඔන්න හිතන්නකො මගේ මේ ස්ටයිලස් එක untidy කියලා. Now I want to clean this stylus. So the stylus is untidy. Unclean. දැන් මම දැනට unclean නෑනේ. මම unclean නම් මට මේක clean කරන්න හිතන්නකො මගේ අතේ ගොඩක් dirt තිබුණොත් then I can clean the stylus. Let's say I'm the cleaning agent. I supposed to clean the stylus. Understood? Then when I clean the stylus, what happened to the stylus? It is get clean. So let's say make it in dusty and I'm going to clean that. Then what happened to my hand? Hand is getting unclean. So the cleaning agent clean it. Cleaning agent get unclean. Same as, let's say I'm the oxidizing agent. Okay, I am the oxidizing agent. Then what would I do? I am oxidizing this. What happened to me? I have to get reduced. Reduce. I'm getting reduced. Understood? The opposite. When I clean this, I get unclean. When I oxidize this, how would I oxidize this? Removal of electron. So this remove electrons. Then somebody has to get electrons. You guys know we never done any of these balanced chemical equations with electrons. Electrons are always swapping somehow. At the end of the day, there are no free electrons. So if I oxidize this is getting oxidized. So this is, oxidation is a removal of electrons. So this is removing electrons. But I have to gain those electrons. What is the gaining of electron? Reduction. So if I am the oxidizing agent, I oxidize this. I get reducing. So what is the oxidizing agent? Oxidizing agent. Species which undergo reduction. It's the opposite. So let's say I am reducing this. What is the meaning of that? I have to give electrons away to this one. This is getting reduced, gaining electrons, oxidation is getting down. What happened to me? I am the one who's given electrons away. If I give electrons away, what happened to me? I am getting oxidized. So the reducing agent is what? Ability to undergo oxidation. Understood? දැන් හිතන්න මේක ඔයගලන් මම මේක එදා ක්ලාස් එකේදී කිව්වා. I don't know you guys have these, like I really love this. සමහරට මේ ඔයාගේ අමහා ගෙදර ඇති these මොනවාද මේ just the firewood stoves. I really love those, like දරාමුරු ලිප. Whatever the reason, I love it. I love these flame and everything, but it's really hard to find them. Itan oy දරාමුරු ලිපක that somebody was cooked something and pot is there, then what happen? These pits and the cinder and everything is just attached to that. The black color suits are there. Then when we are washing from our hand and sponge and the steel scrubber, everything gets really, really blackish. But once you hold it to the tap, everything is getting there. But you're supposed to feel to do that. Otherwise, I don't want to touch food. It's getting my hand dirty. If you think like that, then what happened? You never can do that. That washing can do only somebody's having this, like somebody get used to that, you can do that. Okay, so that if I want to clean this one, what ability I supposed to have? I supposed to have the ability of getting uncleaned. How easily I can get unclean, that easily I clean this one. Understood? So those two are the abilities, oxidizing ability and reducing ability. What is the cleaning ability? How easily I can get unclean. So what is the oxidizing ability? How easily I can get reduced. If I oxidize this one, very easily I have to get its electron to me. Understood? If I reduce this one, very easily I have to give electrons away. So that is my ability of my easiness of getting oxidized. Understood? These six, if you understand these six really nicely, whenever you are going with, like this is like always coming with, even for organic you have a couple of times that we are talking about oxidation and reduction. So this oxidation reduction, this like going to be really easier for you if you today if you have the best understanding of these six. Okay, so the very first one, what is the very first one is the oxidation. What is oxidation? Removal of electrons. Reduction, gaining of electrons. Oxidizing agent, species which undergoes reduction. Reducing agent, species which undergo oxidation. Oxidizing ability, easiness of undergoing reduction. Reducing ability. Okay, then මගේ සුදු මූණ බලාගෙන කියන්න බලන්න මේක බලන්න නැතුව. මේ මගේ සුදු මූණ දිහා බලාගෙන. Can you? Okay, what is oxidation? Removal of electrons. Reduction, gaining of electrons. Oxidizing agent, species which undergoes reduction. Reducing agent, species which undergo oxidation. Oxidizing ability, easiness to undergo reduction. Reducing ability, easiness to undergo oxidation. Alright, let's read. Look at the screen. Let's read. Oxidation, again, removal of electrons. Reduction, gaining of electrons. Oxidizing agent, species which undergo reduction. Reducing agent, species which undergoes oxidation. Oxidizing ability, easiness to undergo reduction. Reducing ability, easiness to undergo oxidation. අපි ඔකට මොකක්ද ගෙදරදී කියන්නේ? ගෙදර මේක කරනකොට මොකක්ද මේකට කියන්නේ? පාඩම් කරනවා කියලා නේද? දැන් මම පාඩම් කියලා වෙව්වා නේද? Do you have the memory? Okay. Read it. Read it. Just give it a try. He like forgot to use the pencil. I guess doing this, Mama think but this is an independent study. We don't have that time. But anyway, I want you guys to complete this and request the marking. Understood? So what you guys can do is you guys can make on this Zoom meeting. Or otherwise, I can make a Zoom meeting for you guys because I have this free, not the free, I mean the paid Zoom and everything. So that you guys can go through this discussion. Make sure every week that I'm going to give you guys this paper. You guys must do that. Doing that, like once you get to this very first term, just your marks going really, really high with these papers. Because these papers are coming from this person who became like, the Idol 6. So make sure go through them, okay? Not difficult, Idol 6, so I'm telling you, very effective questions. Alright, let's check. Oxidation, removal of electrons. Reduction, gaining of electrons. Oxidizing agent, species which undergoes reduction. Reducing agent, species which undergoes oxidation. Oxidizing ability, easiness to undergo reduction. Reducing ability, easiness to undergo oxidation. Okay, we done that part. Let's say this is the trend. This is the trend. Going down the group, now tell me which ability increasing? Oxidizing ability or reducing ability? What is the oxidizing ability? Easiness of reducing. Okay, now tell me, cesium is acting as good oxidizing agent or reducing agent? Reducing agent. Why? Because they lose electrons. Going down the group radius increases, removal of electron is easier. So whoever get those electrons are getting reduced. So these are acting as reducing agent. And along a period, what happened? From here to here, which ability increasing? Reducing ability is increasing. Reducing ability is increasing. Why? So the gaining of electron is easier. Not the reducing ability, oxidizing ability is increasing because they get reduced very easily. So they are acting as good. Which agent? Oxidizing agent. Oxidizing agent. Now tell me, out of these given, which one is the best reducing agent? Cesium. Cesium is the best reducing agent. And the best oxidizing agent? No, no. Think wisely. Are they participating for reactions? No. Then it's fluoride. It's fluoride. You guys know that. Well done. Well done. Your understanding is really nice. Just keep it up. Just keep the way you are doing this. So that let's read with understanding. Read with understanding. Across the period, gaining of electrons is easier than removal because the nuclear attraction is increasing. Therefore, oxidizing ability increases and reducing ability decreases. In a period, best oxidizing agents are at right side and best reducing agents are at left side. Downwards a group, removal of electron is easier than gaining. Therefore, reducing ability increases and oxidizing ability decreases. In a group, best reducing agents are at bottom and best oxidizing agents are at top. So that from here to here, reducing ability increasing. And from here to here also it's decreasing. So that from here to here, this fluorine is supposed to have the highest oxidizing ability. And the same way, from here to here, reducing ability increases. And again from here to here, it increases. So that's why cesium has the highest reducing ability. Understood? Alright, copy this. I know you take time to analyze everything and get here. Once you go home, just try to absorb it a little more. Okay, please. Across a period, gaining of electrons is easier than removal. Therefore, oxidizing ability increases and reducing ability decreases. In a period, best oxidizing agents are at right side and best reducing agents are at left side. Downwards a group, removal of electron is easier than gaining. Reducing ability increases and oxidizing ability decreases. In a group, best reducing agents are at bottom and best oxidizing agents are at top. Okay, this secret is again really easy. Now you guys know how we define oxidation number. Defining oxidation numbers are having set of rules that we're going to do under unit 3. Anyway, as a whole, the easiest way to memorize These are the main group elements. What are main group elements? S block and P block elements are main group elements. If you go with the main group elements, highest oxidation number is directly equal to group number. Highest oxidation number is the group number. So that the group 1 plus 1, group 2 plus 2, 13 to 17 plus 2 to plus 3 to plus 7. And then and that also equal exactly to their valency, maximum valency. Valency means how many electrons you can participate for reactions. So group 1 electron, 2 electron, 33 electron up to 17 7 electrons. That memorize separately. And if you go with the D block elements from 3 to 7, see the oxidation numbers are continuously increasing. Okay, what is this 3D seventh element? This is calcium, that is 4S, and then what is the 3D one? Scandium. Understood? Scandium, titanium, vanadium, chromium, this is manganese. What is the atomic number? 20. No. This is 20. This is not 22. This is 20. Then altogether their outermost shell has 7 electrons. But 2 is 4s. 4s already in this calcium. So what is the total number of electrons of the protons in this 7th one? Manganese. Yeah. So this is the 25th one. Okay. Then what is the last shell configuration? 4s2, 3d, 5. I'm giving you guys this knowledge. This knowledge is not written anywhere. This is the knowledge we're going to get practical when you are doing questions. How many questions you guys done of unit 1? Raise your hand if you done 50 questions. 100 questions. How many? You have to do that all by yourself at home, making a separate timing. Understood? I'm going to do little by little here, but at the end of the day, I'm going to do like roughly, time to time, I'm going to do questions from different places. And then what we do is, I'm going to send you guys a recording. Then you guys are going to go through the recording and get everything. Understood? Before your term test, it's a must. I know whenever I'm asking you guys to do that, you guys feel like a little bored. But later what happens is when you guys are having this big workload, then you guys don't feel like you have enough timing. But when you are starting to do like the big term test, the term test getting closer to examine, they have all these units done. So they are making questions from all units. Then only you would feel like, wow, this is really important. Then we have to go back and do the tools. So don't wait until the last minute, complete that. Okay. I'm doing at the class time to time, but you have to do everything. Okay, so that this has 2 electrons and this has how many? 1, 2, 1, 2. D, where are they? How many more orbitals? 5. 1, 2, 3, 4, 5. See, all 5 electrons are unpaired. So that plus 7 is possible. Removal of all 2 s electrons and d electrons. What happened when you go to the next element? What is the next element? What? Ferrous. Scandium, titanium, manganese, ferrous, cobalt, nickel, copper, zinc. Scandium, titanium, manganese, ferrous, cobalt, nickel, copper, zinc. Again. Scandium, titanium, manganese, ferrous, cobalt, nickel, copper, zinc. Understood? It's easy. Scandium, titanium, manganese, ferrous, cobalt, nickel, copper, zinc. Sorry, scandium, titanium, manganese, chromium. Yeah, chromium. So, scandium, titanium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. What is it? Okay, read it. Scandium, titanium, I miss couple, yeah. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Sorry. Again, let's read it. Scandium, titanium, vanadium. It's in your one, darling. What's your one? No. It's after that. After. No. I think that's 80. Yeah, it's there. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Then Mandhyamala. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc කියලා ඔක high speed එකේ ඔලුවට ගිය දවසකට තමයි ඔයගොල්ලන්ට ට්‍රක් ගාලා මේ එලිමන්ට් එක තියාගන්න පුළුවන් වෙන්නේ. Then you guys have to improve up to that. Not today. You have how much longer? You have 2 years and 6 more weeks, I guess. Yeah, 6 more weeks. Count with this whenever they are having blessed you, when they are having their exams. This is for 2026 year. So you have another 2 more years. But you guys know that 26 කට්ටිය ගොඩාක් ඉන්නවා කියලා අවුල් වෙලා වැරදිලා මම මේ අප chance එකේදී ඒකත් කියන්නම්. So these days I'm doing these 2026 school papers. They have another 6 more years to 6 more weeks to finish this July. Month of August is not the month to do classes. You have to do, it's forbidden to do classes like ahead of 2 weeks. You have to stop classes. Anyway, they are doing really nicely. For 2017 paper, I had 49 out of 50, and that's like almost 100 marks. As she says, she never had any issue with the second paper. But for 2018 paper, the marks was like, a maximum was, all the time maximum was, even for this island ranking was like 46. This time I had 47. But still, the reason they said other 3 are wrong, silly mistake තමයි talented කට්ටියගේ. But some are saying, simplifications are getting wrong very easily. When you are doing a little calculation, in the middle of the calculation, something is missing. Then rest of everything you are doing with that missed part. How would you overcome that? Practice makes you perfect. You cannot overcome that with like waiting that somebody is getting the answer. So, especially I know you guys all doing physics. And also this unit 3 on that 3, 4, 5, and then 6 has calculations. Then organic a little, then again 11th one kinetics, 12th one equilibrium, all the way there are calculations. Tricky, not like normal physics calculations, these are tricky. But some students are waiting until others are putting answers. අර big calculations ටික ඔක්කොම කරගෙන ඇවිල්ලා අර big steps ටික කරගෙන ඇවිල්ලා when there is a big calculation, complicated calculation, there's a prime number or something, you have to divide that, you cannot simplify. Then they are waiting until somebody is putting the answer, or the teacher is putting the answer. Don't wait that. Because to get one single mark for MCQs, you have to get the exact final answer. As an example, let's say that the answer is, for the final exam, answer got like 6.66. Understood? This is the correct answer. Let's say this is answer number 2. But there are other answers as well, like 3.33. 6.88. These are other answers in the path if you do mistakes that you are getting. They don't do like on the exact correct answer arbitrarily, they can put other 4 close by, 6.66 at close by any other 4 answers. They don't do that. What kind of mistakes you guys can do. So other answers are also, in a way, it's convincing, it's correct answers. Let's say, once you do the simplification, you get your answer 6.88. Wow, I got the answer. So this is supposed to be correct answer. Answer is there on the marking sheet. So you got to put that. Understood? So make sure, this is the last thing, this is the thing that I cannot improve during the last couple of weeks. This you have to improve like throughout the whole process. Whenever there's a calculation, try on your own. That is the only way of avoiding the silly mistakes during the simplification. That came through the last week's paper. Anyway, if you go nicely through this path, it's really promising that you guys can get there. Otherwise, it's really, really difficult. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Anyway, so this is the manganese. What's the next element? Iron or ferrous, iron. Okay, so then iron has extra 1 electron, 8 electrons. Then you're gonna pair this again. Another pairing gets here. Another pairing gets here. Then how many unpaired electrons are there? Only 4. So that if you go through, this is become, this is plus 7, this is plus 6, plus 5, plus 4 and so on. 2 of the S electrons and 4 of the D electrons. Understood? Unpairing takes a lot of energy. That's why this cannot increase up to like plus 8, plus 9. It's not increasing. So that this part is for D block elements. D block elements we don't talk until we are going to inorganic unit 6. It's a big part. Understood? Alright. So that this is the part coming with, this is the knowledge that we need for now only for this unit 1. Let's read topic number 4, oxidation state. In elemental form, oxidation state is 0. When combined with another element, which is called the combined form, depending on the ability of attracting electrons, elements can achieve positive or negative values for oxidation state. In main group elements, maximum oxidation state is equal to its valence electrons or group number. Remember that, group number. From group 1 to group 17, maximum oxidation state is equal to its group number. Alright, copy this. Through this path, you guys need this knowledge. So the last paper I was given, what is this number, Baba? Send what is this number? Paper 8. Then I had to give you guys a paper. Is that the paper 7 last week we did? Paper 7 marking. I will post it. Any question? Finish.
One, two, three, two, three, two, one, zero, zero. No, 1 to 3, up to 7, then 2, 8, 3, 3, 2, 5, then 6, 11, 1. First group, 1, 2, 3, 4, 3, 2, 0. Yeah. 0.
හරි හරි ඔයාලා කියන එක හරි. ඔබ කොහොමද ගන්නෙ? 1 2 කියන්නේ 3 4 3 2 1 0. That's exactly correct. Those rules we're going to do under 3rd unit. Remember, this is the common idea, but there are exceptions. Group, this is the second period that you guys are talking about, the second period, only the second period. What are the elements in second period? Okay, lithium, barium, so that's okay. Boron, carbon, nitrogen, oxygen, fluorine. Yeah, maximum possible valency for oxygen is 2, plus 2. Maximum possible fluorine never become plus, that's minus 1. In that sense, that's true. But there are deviations. These are actually deviations. You learn about the deviations. The common stuff I'm just saying here. These are commonly what is happening. Exceptions we're going to do under third unit. Clear? Okay. Copy this. ඔයගලන්ට පොඩි නිකන් මෝඩ කටපාඩමක් ගිහින් තියෙන ඔයවලට නේද? That's okay. You guys are very little then. Finish. Okay, so the fifth one is electronegativity. How would you define the electronegativity? We define electronegativity for any covalent bonding. So the bond supposed to be sharing, and then this shared electron supposed to be dragging towards oneself. So that one has, let's say, if B has more craving for electrons, so we say B has higher electronegativity, A has least electronegativity. And then this person, Pauline, a scientist, he has built up this some sort of a method. Always, let's say, then A is connected to C, A is connected to D, and then check to which side electrons are dragging. By that, he has made this, let's say, C here and D here, so on. He has made this some sort of a series for all these electronegativities, and he was defining a scale to find electronegativity numerically. Now tell me, if you measure all the electronegativities of all these elements, which element is supposed to have the highest electronegativity? Yes. Can? What is this element which is having the highest electronegativity? Think. That's fluorine. Yeah, that's fluorine. Well done. Why? That has the highest craving, highest oxidizing ability. What's the meaning of highest oxidizing ability? So they get electrons very easily from other species. Understood? So they like electrons so much. The craving is greater. That's why they are getting electrons from other species. So that is the definition for electronegativity. Now who has the least electronegativity? Yeah, that one. Sachi, what is that one? That is cesium. Yeah, cesium. Why? Because they always give an electrons away. Why they are giving electrons away? They don't have this craving for electrons. See, you guys are getting. So that they were given these values. Highest electronegativity is 4. Lowest electronegativity is 0. What is the meaning of 0? 0 electronegativity. They don't want electrons. So if they don't want electrons, what is the other conclusion? They are not making bonds. So this goes to what then? Group 18. But usually we say we don't define electronegativity, not 0, because sometimes artificial we can make compounds. Then there is some sort of a electronegativity. Okay, so the electronegativity means relative tendency to attract which electrons? Shared electrons. From where? In a pair of electrons in single covalent bond. Towards what self? Whatever this, the one which is having high electronegativity. This is the electronegativity. Understood? Okay. Let's read. Topic number 5. Electronegativity. Simply we say EN. Relative tendency to attract shared electron pair in a single covalent bond towards itself by an atom in a molecule. Pauling scale is used to measure electronegativity. Again, what is this? Pauling scale again. Pauling scale again. Pauling scale. Pauling scale is used to measure electronegativity. According to that, the maximum possible value for electronegativity which any element can achieve is 4.0. It is assigned for fluorine. The minimum possible value must be 0 since the molecular atom does not attract an electron pair towards itself. But still we don't define it for group 18. See, for group 18, let's read. Elements, electronegativity cannot be defined due to two reasons. Number one, group 18 elements have stable electron configuration which are completely filled. Therefore, it is not necessary attracts an electron. Under normal conditions, they do not form covalent bonds. Only krypton and xenon can form certain covalent compounds under special conditions. In such cases, electronegativity can be defined for those. Then electronegativity across the period, what happened? Value of fluorine is supposed to be increasing. Aduma cesium. So what is the meaning of going down the group? Decreasing. So let's read that part. Across a period, since radiate get decreased, gaining of electrons is easy. Therefore, from group 1 to 17, electronegativity increases. The most electronegative elements are at group 17 and the least electronegative elements or most electropositive. There is no definition for electropositive. It simply means the opposite of electronegativity. Electropositive are at group 1. Downwards the group, since radius increases, gaining of an electron is difficult. Therefore, electronegativity decreases. The most electronegative elements in a group are at the top. The least electronegative elements, the most electropositive, are at bottom. Clear? See all these, like almost all these periodic trends, this is the fifth one we did, are depending on what? All the periodic trends are depending on one single factor. So we will start from that factor to explain everything. Along a period or going down a group. What is that? Saji, loud. යාළුවෝ චුට්ටක් ක්ලාස් එකේ ඉන්න බය නැතුව කතා කරන්න. කියන්නේ? One single factor controls everything. Hasn't කියන්නේ? No. Radius. Radius. In a way we can say atomic number, but going down the group even the atomic number increases, radius is increasing. Along a period when atomic number increases, radius decreasing. So it's directly the radius. Understood? So radius increases, nuclear attraction decreases, losing electrons are easy, so that their reducing ability increases, they are more electropositive. All those are coming through one single factor, radius. Understood? So just get the correlation between all this, so that these are the real electronegativities of all these elements. I was not given this one, but I'm giving you guys the most important one that you're supposed to memorize with values. But still you guys can see from here to here, it's increasing. And any group going down, it's decreasing. Any group, it is decreasing. What do you mean? A negative electronegativity is not existing because We are talking about bond formation. For bond formation, always a must electrons are participating. So not repelling electrons. You never make by repelling electrons. Some sort of a little attraction supposed to be there. So the electronegativity never become negative. Got it? Good point. Okay, so for this one is for you guys. These are the most important part. It's not all, like others are also important, but I have given, you don't need to memorize these values, but from here to here, and this one is a must you have to memorize. And when you are doing Lewis, and not like all level Lewis, Lewis, even I didn't understand how would you draw this, let's say H2O. How would you draw the Lewis of this? Huh? මොකක්ද කරන්නේ? ඔන්න ඔක්සිජන් එක දැම්මා. ඕකේ. ඒ දැන් ඔකට මෙහෙම දෙන්නේ නැත්තේ. ඉලෙක්ට්‍රොනෙගටිවිටි වලින් මොකක්ද කරන්නේ? Don't you guys understand? One is really, really silly. දැන් අර අතනත් කිව්වේ කටපාඩම් නේ ඔයගොල්ලෝ කිව්ව මොකක්ද කිව්වේ? අර 3 1 2 3 3 2 1 කතාවක් කිව්වේ. ඒකත් like you don't know what is happening there, but you memorize. And here you don't know what is happening there. No, darling. The reason is these lone pairs are here. So they need more space. So they are getting closer. Understood? මහාත ළමයි දෙන්නෙක් මහාත ළමෙක් එක්ක චූටි ළමයි දෙන්නෙක් ඉඳගෙන ඉන්නවා. මොකද වෙන්නේ? අර මහාත එක්කලා ඉඳගත්තා නිකම්ම රිප්ලේස් වෙනවා නේද? So how do you do this one? CCl4. Just carbon එක දාලා chlorine හතර දාලා ඉවරයිද? C. On a C දැම්මා. This way. Yeah. I can't right. Anyway. Okay, for advanced level Lewis, we're going to do very soon, we're going to do next week very freshly. I'm actually really, really inspired to start Unit 2. Unit 2 is the one which you start to feel like that the advanced level chemistry is fun and beautiful. Then when you are going to Unit 3, you would feel advanced level chemistry is frustrating and very hard to answer questions. That's how it is going on. Unit 2 is really beautiful. But to do Lewis, it is a must that you have this increasing order memory. Okay. What do you look like? Copy from, start copying from here. Smart measures disturbing at the bottom. Where? Disturbing. Smart measures are to know and praying a more seriously. Not you only can thinking of it. ඔයාලා parents ට කියන්න ඕනේ අම්මේ තාත්තේ අපිට AI එකට අයින් කරලා මේ digital world එකට අයින් කරලා හදන්න නැත්නම් අපිට independent thinking ability නැති වෙනවා. ඔයාලට වැඩි අපිට දක්ෂයි. අපිට වැඩි උඩ හරි මොඩයි. මොකෙම තමයි. දැන් මේ high tech පොඩි බඩු ගෑට් ටිකක් හිර මෙහෙට කරකෙව්වට ඔයගොල්ලන්ගේ critical logical thinking හරි weak. Can I move on? Anyway, I'm going to read this whole part because it's little longer. Once you're done.
Xenon?
Xenon, what is xenon? Okay, what are the elements? Helium, neon, argon, krypton, xenon, radon. Just write within bracket group 18 if you've forgotten. Done? Let me read that part first, then let's copy the rest of everything. Let me read. Look at your note. Check your note. Electronegativity. Relevant tendency to attract shared electron pair in a single covalent bond towards itself by an atom in a molecule. Pauline's scale is used to measure electronegativity. According to that, the maximum possible value for electronegativity which any element can achieve is 4.0. It is a sign for fluorine. The minimum possible value must be 0. Since the molecular atom does not attract an electron pair towards itself. For group 18 elements, electronegativity cannot be defined due to two reasons. Group 18 elements have stable electron configuration which are completely filled. It is not necessary attracts an electron. Under normal conditions, they do not form covalent bonds. Only krypton and xenon can form certain covalent compounds under special conditions. In such cases, electronegativity can be defined for those. Across a period, since radius get decreased, gaining of electrons is easy. Therefore, from group 1 to 17, electronegativity increases. The most electronegative elements are at group 17 and the least electronegative elements, most electropositive, are at group 1. Downwards the group, since radius increases, gaining of an electron is difficult. Therefore, electronegativity decreases. The most electronegative elements in a group are at top. The least electronegative elements, the most electropositive, are at bottom. Did you write everything? Are at bottom. Okay. Complete this.
Why is it element at bottom like
What is it? What is it? Somebody. Francine. Francine. Francine is radioactive. Francine. Everything is in the periodic table I given you. Finish. Okay. Factors affecting the magnitude of electronegativity. Radius. What is the connection? Radius and electronegativity? How do you guys know? Radius smaller, electronegativity is greater. Okay. And then the second one is charge of the atom. What can you say about the charge of the atom? Charge is supposed to be what? Negative or positive? When the charge is positive, electronegativity high. Why? Likewise, protons in the nucleus is high, so that the rest of electrons are gaining more attraction. See, for normal lithium atom, neutral lithium atom 1, but once you gain it a plus charge, it's increasing up to 2.5. And see another condition, even for negative. See, normal neutral fluorine is 4, once you gain 1 electron, අර බබාලා 7 දෙනෙක් ඉන්නේට adopted child කෙනෙක් දුන්නාම මොකද වෙන්නේ? It's rejecting. It's difficult. So it's decreasing. No more that attraction on kids. Understood? Everything is relative. Do you guys know that? Everything is relative. Even all our desires, our beauty, and all our requirements, everything is relative. Sometimes the things we want in this country, if you live in another country, those are become very, very negligible. Likewise. So it's relative. And this one again, what happens? See, when the plus charge is increasing, what's the meaning of increasing plus charge? More and more electrons given away. Then what happened to the craving for electrons? More and more increasing. So when the plus charge is increasing, electronegativity going down is also increasing. That is the second one. Okay. And then the third one. Okay. So, what is the shape of s orbital? Symmetrically. S. Okay, what is the shape of p orbital? You have the book with you. Huh? බෑනේ and keep circular කියන්නේ මොකද්ද circular කියේ බෝනේ බෝ තමයි circular කිව්වේ කොහමද what seriously we never talked about come on don't say such words is it all over oval shape what is the shape of s orbital what is the page number 47 page number 47 s orbital shape symmetrically spherical. P orbital shape? symmetrical dumbbell. Let's say this is symmetrically spherical s orbital and it has this big electron cloud. Okay, electron cloud is everywhere. Okay, spherical mean this is 3D. Okay, then let's say another orbital, whatever it is. Let's say this is hydrogen has to join with another, let's say chlorine. Okay, what is the last shell electron configuration of chlorine? Empty, fluorine, chlorine. What is the period? මගේ fingers දිහා බලන්නකෝ. Clear? Because the very first orbital, very first period is empty. Why is that? Only hydrogen and helium are there. Middle six are empty. So when you are counting, always count like empty. And then fluorine, chlorine. The period is 3. Group is 70. Group 70. Then what's the last shell configuration? 3, S2, 3, P, 5. Get the practice, get the practice. Understood? Okay. So that, okay, now the last, the electron, next electron want for which orbital? To complete octet, to complete 6 full. So this needs one single electron. So that electron is supposed to go on to P. Understood? So what is the shape of this P orbital which is trying to, hello? Quite together. Okay, so that to complete the octet, one single electron supposed to be get there, but to get to what orbital? To p orbital, so that its shape is symmetrically done there. Clear? Let's say even s orbital or p orbital are now trying to mixing with this s orbital. Is there a direction? There is no direction. Let's say 1, 2, 3, 4, 5. All these different 5 directions. Any of these orbitals can come and mixing with s orbital. Clear? Because it's 360 symmetry. So that they say highest possibility of mixing any orbital is easier for, highest possibility is having for s orbital. So that they say if others can reach very easily for s orbital, they say s orbital is supposed to have the highest electronegativity. Understood? Because they can get electrons from whatever the direction. Let's say if this is P. If this is one of the P and then the other P, one of the P, this is one of the P and then the other P has another 2 possibilities. Let's say this is the other P. If a P comes, okay, if a P comes. So this is the first possibility. Either it has to come through this axis or the other possibility is this. Either it has to come through this axis. Clear? Only 2 possibilities are there. So that the electronegativity of craving for electrons, desire of keeping electrons with P is less comparing to S. So that they say whenever S is participating more for one formation, then electronegativity is greater. So that when 1s and 1p is participating, half S, percentage is 50. 1s and 2p participating, 1/3 of S, 33. When 1s and 3p, 1/4, that is 25%. Are you guys okay how to calculate these percentages? Understood? If you have 1s, this is 1:1. 1:1. So that is half. Understood? If this is sp2, this is 1:2. Then 1/3 and so on. So they say once you calculate this one, and then when the S character percentage is greater, electronegativity is high. So that from here to here, going from 25 to 33 to 50, S character percentage greater, so that the electronegativity is greater. Understood? Mixing these orbitals, overlapping these orbitals is called hybridization. Hybridization is a very big, very sophisticated, very beautiful, complicated but easy part under unit 2. Understood? So that's why I have not kept spaces here. Just understand this way, but later we're going to do this big for next unit. And then this one again, out of these three, now tell me which one has higher electronegativity. Which one? Plus one. What is the reason? Because it has a plus charge. Plus charge means already given electrons away, taken electron is easy. But to do that, you're supposed to know the hybridization. If the hybridization is same, then we're going to move on with the charge of the molecule or ion. Understood? That part again is not that easy to understand. Then you have to wait until we are moving to second unit. Clear? Alright. So let's read one by one and let's write the way you understood. Okay, so the topic, factors affecting the magnitude of the electronegativity. Number one, radius. When the radius of the atom is small, gaining of electrons is easy, therefore electronegativity increases. Okay, is it completed? Yes. Or completed? Is small. Therefore, electronegativity increases. Why? Okay, moving on to the second one. Number two, charge of the atom. In cations, gaining of electrons is easy, therefore electronegativity increases. For anions, gaining of another electron is difficult, therefore electronegativity decreases. Higher the charge of cation, electronegativity increases. Alright, copy this. There is nothing to fill here. And then make it a now. And is there anything to fill? Other space is there, space. Fill the space. Okay, again here we are coming to another little important part. That is the sixth periodic trend. So we have another two more to go after this one. But this is little like not the complicated, but you guys have to understand this nicely. Okay, when they are asking these questions like for these MCQs, like let's say multiple choice questions, so they ask you guys to understand either correct statement or incorrect statement. If they would say electronegativity of second periodic elements gradually increasing, is this statement correct? Electronegativity of group's second periodic element is gradually increasing. That's correct, gradually increasing. Or the radius is gradually increasing. So that's again, decreasing. That's again correct. So the electronegativity is, first ionization is increasing this way. Can we say this is gradually increasing? We cannot say that because here you guys can very obviously see increasing, decreasing, increasing, decreasing. So that this is called the zigzag nature, zigzag. So you have to say increasing towards group 18, but in a zigzag way. You cannot say just increasing, that's wrong. Understood? And let's see why they are having this kind of a pattern, And I want you guys to focus really, really well. Because from the first ionization energy, we are moving to this second ionization energy and also the to the third ionization energy. You guys have to understand this one. So for that, I want you guys to focus really well with this. Alright. So, you guys need this best knowledge with electron configurations when you are moving to the second unit. So memorize these elements, their position, and then the valence electron. Just do the tilt. You will get the knowledge then. Today, after once we did this part, if you have enough time, you get the tilt as well. Go through the tilt so that you get this best practice with the tilt. Go through the tilt. Okay, so the first element is I have taken is lithium. Lithium belongs to which group? The very first group. Okay, what is this full electron configuration? 1s2, 2s1. What happened here is, what is the ionization energy? Removal of electrons. Removal of electrons, to remove electrons, you have to break this nuclear electron attraction. Then you have to provide energy. So it's always endothermic. Okay. So you're going to provide less energy for lithium. That's because once you remove this 2s1 electron, what is the next configuration of lithium plus? That's become 1s2, which originally belongs 1s2. Which element? Helium. And that is an inert. Understood? So by removing one single electron, it can reach inert configuration very easily, so that the may zoom to tired of E11. So that's why it's not writing whatever I'm showing you guys. It takes time to show you guys what I'm writing here. So that once you remove one single electron, since it's reaching this inert configuration, removal of this electron from lithium is easy. So its first ionization energy is less. Then I'm moving on to beryllium. Electron configuration is 1s2, 2s2. What is this 2s2? Some sort of a completely filled stability is there. Even it's a small shell, small sub-energy level, small orbital, but still, removal of those two electrons, it takes energy to unpair the electron. So because of that, comparing to lithium, this is high, plus lithium has 3 protons, beryllium has 4 protons, so that again, nuclear electron attraction is greater, so removal of electron is difficult. But then when it comes to boron, see, the configuration is 1s2, 2s2, 2p1. So which electron is getting away now? 2p1 electron is getting away. After you remove the 2p1 electron, then you are reaching some sort of a little stability. Not the full stability, but halfway, the incomplete, some sort of a half field stability is there. So that the removal of this electron is easy, so its ionization energy is less than ionization energy of beryllium. Understood? So this axis is ionization energy. Are you okay? But there is no such special ability here. Carbon, 2s2, 2p2. Even if you remove one electron, you are going to 2s2, 2p1. There is no special stability. So there is a normal increasement because from boron to carbon, proton number increases, nuclear charge increases, so that the ionization energy has been increased. And then going from carbon to nitrogen, C, 2s2, 2p3. What kind of stability is that? Half stability, half field stability. Clear? So that half field stability, if you remove one single electron, where are you going? You are going to 2s2, 2p2. So that is disturbing this current or the existing stability. Nitrogen doesn't like that. So you have to provide big energy to remove an electron from here. That's why this is greater, and that's why oxygen is less than that. Oxygen configuration 2s2, 2p4. By removal of one single electron, this has become 2s2, 2p3. Reaching stability by removing this electron is easier. So they like to exist in half field stability, so that this ionization energy is less comparing to nitrogen. Nitrogen is greater, oxygen is less. Understood? Okay, this is again normally, since the proton number increasing, it's increasing. Higher stability is going to neon. Why is that? What's the configuration? Yeah, very inert. Octet 2s2 2p6 is completely filled. So that's why it has the highest ionization energy. Understood? Why group 18 always getting highest ionization energy? Highest first ionization energy. Why? It has inert configuration. Why group 1 always show the lowest first ionization energy? Oh, first ionization energy. What is the reason? Always the lowest. By removal of one single electron, even sodium, even potassium, that's the lowest. They go to the inert configuration. Understood? That is the reason. Are you guys okay there? All right. So, නෑ ඔය පාට එක තනියම ඔයගොල්ලෝ කරන්න. හරි මේක කියවන්න. Topic number 6, first ionization energy. Variation of first ionization energy of elements in main group have a zigzag pattern. Copy that. Okay, when you are drawing this one, when you are putting these numbers, make these numbers little smaller, otherwise it's overlapping with the line down there. On the line, you're going to write this one as well. Hang in. Okay, so what you're supposed to do is, you're going to draw a couple of pencil lines here. Just listen. Okay, I'm a pencil lines, you're just going to draw them, and then the very first one down here, and then this one's supposed to be top, and when you are drawing the beryllium boron one, you have to draw this one in between these two, this one here. Don't draw like this, some do, like even after I explain some do, draw this one here. Also say this triangle and then when you do this one, then the next line is parallel, this line is parallel to that. Then marking is really easy. Understood? Hanging, still hanging. Okay. You need to have this big memory. Today we're going to do a couple of questions. Then how would you memorize? 1, increasing, decreasing, increasing, decreasing. How is to memorize? You guys have to memorize. Lithium, increasing, decreasing. Memorize that way. Alright. Okay, what is the very first step when you're drawing any sort of a graph? What's the very first step? Axis naming. Okay, start from that. Name axis and then draw the middle. I will magnify once you've done axis. Online kids, make sure you guys are getting these really nicely. And plus, you guys have to ask me questions. Online kids, I don't like that. Maybe other online classes, they don't have interactions. But I want you guys to interact with me, to ask me questions and everything. Alright, now copy the middle part. One of these actually was doing that. Anybody saw that? Saatnya pretty head prefectural. That's not yeah, but she's been really good. I don't know how much research she will get, but she is really good. Let's see. Something in the middle? Yeah, it's correct. can do this with a pen and you can really place, this pencil like parallel lines, not necessary, right? We were drawn all these parallel lines just to make sure that you guys are drawing this nicely. Once you've done this one using pencil, using pen you can complete everything so that you can delete those parallel lines. You don't see those lines on my diagram. Write electron configurations as well. What do you want, darling? Okay, the next line there is to write the increasing order of ionization energy. Could you do that? Use a pencil, otherwise I want you to write the increasing order, not the given order. Increasing order. Done. The very first one is the lowest one, and that is the lithium. And the next one is boron, and then beryllium. Make sure this is where you have drawn, and then carbon, and then oxygen, and then nitrogen. After that, fluorine. After that, neon. And see what is the next down elements of lithium: sodium, boron, aluminium, beryllium, magnesium. Next element of carbon group: silicon, oxygen, sulfur, nitrogen, phosphorus, fluorine, chlorine, neon, argon. So you have to memorize this. Sometimes I would do today. Sometimes they do questions you get only using this diagram. Sometimes you can very easily get knowing this one. Then you have to memorize both. But still sometimes they ask not questions from the second period but questions from the third period. Then you need that memory as well. Okay. Use another color and copy this one. I have just written this one beyond below this element. Below the element I have written the next element. Just write that as well. China, can I move? Yeah. Polishing you can do at home, I guess. Yes. Okay, this last point. Downwards the group, i.e. one get decreased. Downwards the group, i.e. one get decreased. I need less extra time to do a couple of questions today to convince you guys this ionization energy trends. Okay. Factors that affect first ionization energy. The very first one is the radius. What is it? The radius. When the radius high, first ionization energy is less. Radius high. Removal is easy. Less energy needed. So the ionization energy is less. And then the second one, the electron configuration. So the electron configuration thing goes with that half field and completely field stability. So this is half field stability. So that stability greater, so that the ionization energy of nitrogen is greater. And then oxygen less stable, so that to remove this electron to get here is easy. So the oxygen has less ionization energy compared to nitrogen. Clear? First ionization energy. And this doesn't have such special stability, but sort of saying, not the half filled, but this is a fully filled 2s2 high stability, so that the ionization energy of beryllium is greater than boron. This one, losing one electron, can go here very easily, so that ionization energy of boron is less. But still, same way, for group 2, 15 and 18 are having the highest stability. Group 2, what is the common configuration? N, S, 2. Group 15, N, S, 2, N, P, 3. 18, N, S, 2, N, P, 6. See, half filled, completely filled, so the stability is greater. And then nuclear charge with the ionization energy. When the nuclear charge increases, ionization energy is high or low? High. Because nuclear charge increases mean we have to give more energy. අම්මේ වාට ගොඩක් ආදරේ නම් මෙයා මෙඩිකෙන් කඩලා එළියට ගන්න ගොඩක් අමාරුයි නේද? අම්මලගේ තාත්තලගේ ආදරේ අඩු attention අඩු ළමයි තමයි හරිම easily third party එකට attraction තියෙන්නේ. So third parties at attraction සදාගන්න එපා. අම්මි තාත්ති ආදරේ නැත්නම් like a shielders. They have always other stuff to do. So it is maybe less attention, but amma තාත්තගේම most precious treasures තමයි kids කියන එක. Never forget. Okay, shielding effect is increasing, then ionization energy decreasing. Shielding effect means you are getting away from your family. Then it's very easy to get you out of the family. Understood? You need less energy to distract you, get you out of the atom when the shielding effect is greater. Medical break එක Alright. So just writing 1, 2, 3, 4 is enough. Let's read it. Factors that affect first ionization energy. Ionization is an endothermic process, so that is positive, absorbing energy, so your energy is high. Therefore, during the process, energy is absorbed from the environment. Neutral atoms are stable since they have same amount of electrons and protons. To remove electrons, energy has to be provided to overcome nuclear attraction. Fill this part. ionization is an endothermic process. Therefore, during the process, energy is absorbed from the environment. Neutral atoms are stable since they have same amount of electrons and protons. To remove electrons, energy has to be provided to overcome nuclear attraction. So the very first one is the atomic radius. Let's read. When the radius is small, nuclear attraction is high. Therefore, more energy should be provided to overcome nuclear attraction. Therefore, smaller the radius, ionization energy increases. See, group 1 lithium and sodium, smaller, larger. So the sodium is larger in size, so its ionization energy is less. Okay, copy this. So, did you finish? Okay. Number 2, electron configuration of the element. If the element is having a stable electron configuration, removal of an electron is difficult. Therefore, ionization energy increases. This is half-filled more stable, 2p3, can be stabilized by removing an electron, so the ionization energy is less. If you go with the stability of nitrogen is greater, so that ionization energy of nitrogen is greater. If the element is not having a stable configuration, but if it can achieve a stable configuration by removing an electron, removal of an electron is easy. Therefore, ionization energy decreases. Same thing here. Again, see. Beryllium already having fully filled more stable. If you go with the stability of beryllium is greater, but the stability of boron is less. Can be stabilized by removing one single electron. So that removal of this electron is easy if you go with the ionization energy of boron, so that is less. Next point, if the element is having a stable configuration and also if it cannot achieve stable configuration by removing electron, removal of electron is difficult. Therefore, ionization energy increases. Those are for group 2, 15 and 18. That's why here in this diagram, see group 2, 15, 18 are different from others. Okay, metric කර. මෙතන ඉඳන්. අපි පළවෙනි කිව්වලා මෙතන ඉඳන්. metric copy කරගෙන copy from here. Is it okay to move up here? Okay, this is all. Done. After the break, we have මේ දෙකත් ඉවර කරමු. එතකොට අපිට new topic එකට යන්න පුළුවන්. Okay, topic number 3. So we can start with the new topic after the break. Nuclear charge. When the nuclear charge is high, electrons are strongly attracted towards nucleus, then ionization energy increases. Number 4, shielding effect. When shielding effect is high, repulsion from inner electron increases, then ionization energy decreases. Let's fill it out. Yeah, we have to start with the questions. Done. When the nuclear charge is high, electrons are strongly attracted towards nucleus, then ionization energy increases. Shielding effect. When shielding effect is high, repulsion from inner electrons increases, then ionization energy decreases. Okay, see the trend. This is the second period and this is the third period. And you guys can see from here to here, see helium, neon, argon, krypton, xenon, all the way it's decreasing. Each group is decreasing. From here, lithium, sodium, potassium, rubidium, cesium. Again, little, but still this decreasing. What is this element? Yeah, that's hydrogen. See, where does it remain? In between somewhere here. Okay, so this is again from a resource book. After that, we are moving to this seventh topic. How much time for the break you guys need? It's, let's say, 10:10. Then 10. 15 minutes enough? Or you guys want 20 minutes? Or none? Or yalu podda yalu godak kenewana thaman godak ඕන වෙන්නේ breaks. Breaks යනවා දැනෙන්නේ නැහැ yalu ඉන්නකොට නේද? Okay, I'll give you guys up to 10:25. Okay? Online kids get here at 10:25. Okay, online kids, let's start back. Second ionization energy. All right. Okay, concentrate really well. So to get the second ionization energy, you guys have to understand the very first ionization energy trend very nicely. Okay, initially let's say lithium has 1s2 2s1. Is it readable? The configuration? Yeah, 1s2 2s1. Which electron is getting away? 2s1 getting away, then you are going to 1s2. 1s2 configuration belongs to who? helium. Helium. So, removal of electron from 1s2 is really difficult. It is like you are removing an electron from helium. So, this is the second ionization energy. This is the second ionization energy. First ionization energy of lithium, second ionization energy of lithium. First ionization energy of group 1 lithium is the lowest, but the second ionization energy of the group 2 lithium is the highest. Why? Once you remove one electron, next electron is going from inert configuration. Understood? Alright. Okay, so then I'm moving to third ionization energy. So 1s2, which electron is getting away as the third electron? The very first electron was 1s1, and then the second electron was 2s1. The very first electron was 2s1. On ඉස්සෙල්ලාම යනවා IE1 is 2s1. Then IE2 is 1s2. And then IE3 is 1s1. Now you have this configuration. Removal of that electron is then easier. So removal of one single electron. Let's say this is not 1s1. Let's say this is 2s1. Then inside you have 1s2. Understood? Let's say if this is not lithium, if this is sodium, then 2s2, 2p3, 3s1. Understood? 2p6, 3s1. Understood? So the removal of this electron is really easy, and the removal of next electron is really difficult. And then once you break this, once this become 2p5, then the removal of next electron is easy, because it's going from 2p5, unstable configuration. Okay, so as when I'm moving to this beryllium, what is the first electron removing? 2s2 electron. So that ionization energy is little high comparing to lithium and boron. But once you remove that electron, your configuration becomes what? 2s1. Then the IE2 gets away with this electron. IE2 is which electron? 2s1 electron. 2s1 electron. Now this has one single electron. So the removal is easy. That's why this is this is lower. Understood? Okay, this is boron. Which electron is going first? 2p1 gets away. Once you remove the 2p1, what is the next configuration? 2s2. 2s2 is higher, so that the removal of that easy, so this is greater than these two. And then carbon. Okay, very first electron gets away from 2p2. And then once you remove one electron, the remaining is 2s2, 2p1. Removal of this electron gives some sort of a stability. So that removal of 2p1 electron is easy, so that the ionization energy is less. Understood? Okay, see, when you go through this path, carbon, carbon, and then what is this configuration?
2s2.
Just 2s2, 2s2. That's why it is greater than other two. So this is the, okay, red one is the first ionization energy. So this is the very first ionization energy, and this is the second ionization energy, and this is the third ionization energy. Understood? So if they ask, how would you explain this trend, you always have to explain likewise. Okay, shall we go to this one? Explain. What is the larger configuration for the first ionization energy? 2s2, 2p1. Okay, just a normal. So there is nothing else is there. And then why this is less? Why this is less? Yeah, it's already unstable, and there is actually this is more stable. That is what happened. And then This is, which electron is getting away? 2s2 2p4 electron. Once you remove 2p4, once you remove one single electron, you are coming to 2p3. See, that's why this is greater. See, oxygen. 2p3, here 2p4 become 2p3. This is oxygen. Then 2p3 has the half stability, same. Understood? Okay, for your final exam, you need only the first ionization energy and second ionization energy. But sometimes they are asking questions from the third ionization energy. Time is very critical thing for the final exam, so I want you guys to memorize all these three. Once you go home, you're supposed to draw this one with understanding, not just like memorizing this. Understood? Okay, see. If you go with the very first ionization energy, out of all these, what is this part? Next period sodium. If you go, next group sodium. So this is lithium. So this is sodium. Sodium ionization energy is supposed to be less because its radius is greater. Sorry. So that I'm going to just forget this part. Let's go here. This is the first ionization energy. And let's say this is the second ionization energy. And let's say this is the third ionization energy. Okay, if you go with the very first ionization energy, which ionization energy is the lowest? Forget sodium. Which ionization energy is the lowest? First ionization energy of which group is lowest? Group 1 is lowest. Which group is highest? And group 18. Group 1 and 18 for first ionization, lowest and highest. I'm moving to second ionization energy. Now tell me, which ionization energy is the least? So which element? Beryllium. What is the group? Group 2. And then the highest? Group 1. Are you following me? Third ionization energy. Which group or which element is having the least ionization energy? Yes, this is 13. And then the blue set, which one is the highest? Group 2. Can you guys see some sort of a pattern? Okay. Lowest first ionization energy go to which group? Lowest first ionization energy goes to group 1. Lowest second ionization energy goes to group 2. Lowest third ionization energy? Lowest sixth ionization energy? Group 16. Lowest fourth ionization energy? Group 14. Why is that? Once you remove valence electrons, you are reaching inert. Then the next one is supposed to be the highest. By removing valence electrons, since you can reach inert, you are removing that electrons very easy. Understood? That's why it's lowest. Understood? Okay, now the lowest. I'm moving to now highest. Okay, IE1. Which one is having the highest ionization energy? Which group? Group 18, IE1 highest. IE2 highest. Group 1. Group 1. IE3 highest. Group 2. Why highest IE2 goes to group 1? Once you remove the last shell first electron, final electron, one single electron, next one is coming from inert. Why the third ionization energy of group 2 is highest? Once you remove 2 electrons, the third electron is coming from inert. So it's always, if you get the group number, if you add one single to that, that is the highest ionization energy. If let's say it is IE5, which ionization energy is the highest for IE5? Once you remove that number of electrons, next one supposed to coming from inert. Okay, IE5. Which group has the highest next ionization energy? Okay, IE5. Which group has highest ionization energy? IE5. Group 5. Once you remove fifth electron, sorry, my question is okay, if I go again from this one, who has the highest fifth ionization energy? Which group has the highest fifth ionization energy? Group? No. Group? No. Highest fifth. Highest fifth. Removal of 5 are easy. Sorry, removal of 4 are easy. Fifth one is difficult. Group. Once you remove the inner electrons, removal of last electron is difficult. Last electron is IE5. Why IE5 is difficult? Because it's coming from inert. Then how much is supposed to be in outermost shell? 4. Understood? Always plus 1 is the difficult one. Okay. IE4. Highest for which group? IE4 highest. Removal of fourth electron is difficult. That's because fourth electron is coming from inert configuration. Then that is group 30. 3 electrons are in outermost shell. Fourth electron is in inner shell. Removal of fourth electron is difficult. IE4 is highest for group 30. Okay, IE7 highest. Now you guys get it. IE5 is highest, group 14. IE2 is highest, group 1. IE2 is highest. IE3 is highest, group 2, and so on. You guys get it now. See. So that for whatever this group, if you go with this minimum, that is exactly the same IE value. Why? Once you remove that number of electrons, the next one is inert. So reaching inert, you remove your number of these valence electrons very easily. But then the maximum IE is 1 above n plus 1, because inner shell has how many number of electrons? Removal of that, the next electron is going from, outer shell has that number of electrons, so that the next electron is going from inert configuration. I guess okay there. Okay, and then now tell me, highest IE1 goes to which group? Group 18. Highest IE2, group 1. Highest IE3, group 2. Lowest IE1, lowest IE2, lowest IE3, 13. Are you guys okay here? Are you guys following me? Alright. I want you guys to complete this way. I want you guys to draw as possible as these electron configurations. Okay, complete this. Second ionization energy, IE2. And I think මේකේ පාර්ට් එකක් දාලා තිබුණා මම දැන් ඒක මකන්න ඕනේ. ඒක තමයි ඒක IE1 වලත් තිබුණා ඒකනේ. And axes are already named. And I want you guys to copy. And I mean not the copy. With understanding, try to write other electron configurations. බෑනේ ඉලෙක්ට්‍රෝන ගානයි ප්‍රෝටෝන ගානයි ගැප් එක වෙනස් නේ. ආයි අහනවා ප්‍රශ්නේ මේකයි නෑ දැන් ඉලෙක්ට්‍රෝන වැඩිපුර ගිහිල්ලානේ ප්‍රෝටෝන ගානත් වෙනස්. Understood? Protons are different, electrons are different, so these two never become same. Nuclear attraction is different. Just with understanding, try to write this one. I'll give time, otherwise if you copy this one, once you go, you would feel like unclear. Are you guys okay here? Going from one by one? Okay, feel the rest. Feel the rest by yourself. If you are comfortable, feel it. I mean, feel the rest of the part, like the rest of the note. Minimum, maximum. Minimum, maximum. Highest IE, lowest IE. Feel that part. Use a pencil if you feel uncomfortable, otherwise, like, you know, you are making your note messy. Done? Say no? Confusing? No. Just give it a try. Give it a try. If I show you guys the answer, you guys are not improving. China, okay. Done? Everything? The full part? Yeah, complete everything. Complete everything. Yeah. Same page, complete everything. Erase එක message. Oops. Erase. It is clear. It is correct. Sachi වයිටානේ. හා? පැටලෙන් තන කියන්නකෝ. හරිද? Seno, he found the eraser. Moving on, this set. Check your answer. If you understood this, oh, that's the day. What are the other? Saji, are you done? Still doing? Yeah. හරිද? Okay, this is a seventh trend. Last one is only, this is the last one. Electron gain energy. So, what is the ionization? Ionization, removal of electrons. Electron gaining, opposite of that. Neutral atom gaining electrons, making what? Unit negative anions. Unit negative anions. Clear? Okay, so this gives the idea of tendency of accepting an electron by isolated atom to form an ion. And then the definition I'm just giving. Energy associated, we don't say it is because it's either exothermic or endothermic. So we cannot say energy obtained or energy releasing. We cannot say that. So energy associated with what? Gaining of one electron. See, one electron to gaseous atoms. See, this one's supposed to be gaseous to form unit negative, one negative, and this also supposed to be gaseous ion. For chlorine, this value is minus 349. Okay. What is the last shell electron configuration of chlorine? Empty fluorine. So third one, group 17. 3s2, 3p. Hey, chlorine. 5, group 17, 5. How many electrons supposed to get to complete the octet? One single electron to go to S2P6. Okay, then why this is negative? Because very easily by gaining an electron, it's complete the octet. So to reach octet is easier by gaining electron. So they say, okay, get my energy. I'll give you guys energy, just give me an electron. So by gaining electron, they are stabilizing. Thermodynamically, which systems are more stable, exothermic or endothermic? Exothermic systems are more stable because thermodynamical energy is less. So they are getting stable by releasing energy. That's why this is a negative value. Clear? Alright. So there are a couple of factors to think about. What do you think then the electron gain energy of, let's say, phosphorus? Okay, let's say arsenic. What is the last shell configuration? Empty, nitrogen, phosphorus, arsenic. Period 4. Group 15. Nitrogen, phosphorus, arsenic. Understood? Group 15 configuration is S2, P3, but this is from fourth period. So 4s2, 4p3. Okay, what happened with this one? Do you think this would love to get electron to this? No, because half stability is always already there. But they have to participate for reactions, they have to get electrons in, but they don't like to do that. So what do? We have to forcefully give electrons in. We have to forcefully give electrons in. If we are give forcefully electrons in, what do we have to do? We have to give them excess energy. So that value is what? Positive. That's endothermic. Understood? So electron gain can either be exothermic or endothermic. So this value either can be negative or positive. This can be negative or positive. Understood? Okay. Let's read. Electron gain energy, the symbol is Eg. This gives the idea of tendency or accepting an electron by isolated atom to form an ion. So the Eg1 for first electron gain, Eg2 for second electron gain, and so on. Example, first electron gain energy symbol is Eg1. Energy associated with gaining of one electron to gaseous atom to form uninegative gaseous ion. So Cl gas gain electron to become uninegative Cl minus gas. Value you don't have to memorize. I'm just giving to get the idea. It's minus 349. Okay, copy this part. Since this is a definition I will give you guys. Energy associated with gaining of one electron to gaseous atom to form uninegative gaseous ion. Accidentally uninegative gaseous ion. Isn't just drink some water, darling? This is not the time to yawn. You feel like your eyes are swelling or something. Are you feeling tired of your eyes? Because for us, we feel like you had like late night sleep or something. You awake a lot kind of feeling we get like looking at your eyes. No. Maybe we will not get used to look at you without glasses, I guess. Okay. Factors affecting electron gain energy. Atomic radius. Okay. When the atomic radius is small, what happens to gaining of electrons are easy or difficult? Easy. Easy. Radius smaller, more attraction, it's easy. Then what happened? Easily gaining electrons mean they remove more energy for gaining electrons. So what happened? The negative value of electron gain is increasing. So if it is easy, very easily they are gaining. So you don't have to provide energy. So it is releasing energy. If the easiness is greater, release energy is greater, so you become more stable. Are you okay? Ask me, what is the question? Okay. අපි ආස දෙයක් ගන්න අපි වැඩිම සල්ලි වියදම් කරනවා නේද? It's something like that. You are purchasing something. If you feel like it's really, really good, regardless of price, you are getting that, even if it is pricier or if it is easier to obtain, like not easy, harder to obtain in our version. Or otherwise, what happened here is, so when you become more and more stable, you are releasing more and more energy. So when the nuclear charge is greater, very easily you are gaining electrons in. මේ කියන්නේ negative positive එකතු වෙලා. මේකේ plus part එකකුත් තියෙනවා minus part එකකුත් තියෙනවා. Okay, when the size is smaller, plus part is very, very less. Then the releasing part or negative part is high because it's exothermic. Endothermic part is also there, such if you don't understand this one, what happened here is, when you are smaller, only there are other incidences is there, I'll come to that later. Let's say when you are smaller, gaining of electron is sort of difficult because electron repulsions are there. Understood? So part of energy is using, part is endothermic. But at the end of the day, nuclear has more ability to gain electrons very easily, so that they release some energy as well. Understood? So that the negative part wins when the nuclear size is less. Understood? So both sides are there. And then once you go with this, you would understand this better. And then the electron configuration. So the electron, not only the nucleus, but also the electron configuration. NS2, NP3. What happened here? We need to do reactions, but still the existing configuration is stable. So not easily they get electrons in. So forcefully, by our force, we have to add the next electron to convert this electron configuration to NS4, which is disturbing the half stability, so that we have to provide electrons in. At that time, this value is plus. And again, except for phosphorus. So group 2, NS2, 15, NS2, NP3, 18, NS2, NP6. But still, except for phosphorus. With the phosphorus, the condition is comparing to nitrogen and phosphorus. Phosphorus is really larger. So that this energy using for this electron repulsion is less. So less positive energy, high negative energy, so that the value become negative. But for nitrogen, since it's smaller, to overcome this electron repulsion, it needs more energy. Negative is there too, because it's electronegative. To release electrons, to gain electrons, it like to do that, so it is releasing energy. But this is greater. Since this is greater, resultant electron gain energy become positive. Understood? For phosphorus, it's negative. Okay, that is the second one. Okay, so this is at the end of the day, this is what happening. So group 2, 15 and 18 not usually we are specifically giving values. These are positive values other than phosphorus. See, all the other values are negative values. May occur negative values because very easily they remove electrons. Okay, now tell me, there is another something to think. May then again value the electron gain energy of fluorine and chlorine, which is supposed to be greater. Supposed to be greater for fluorine because it is more electronegative. So that it has to release more energy and the size is smaller. It has to release more energy by gaining electrons. But the value is higher for chlorine. That actually is the highest value. Highest electron gain energy always going to chlorine. What is the reason? Because this takes, so the plus and minus both are there. If you go with fluorine, plus is to overcome electron repulsion. Minus is to, when they are gaining electrons, they are losing energy because it's stabilizing their configuration. But still, this plus is considerably greater compared to chlorine. Understood? Because chlorine is larger. So that inside the chlorine, electron repulsion is less. So here the plus value is less compared to plus value of fluorine. Understood? So that even the minus values are winning for both these. Since the plus value of fluorine is high, resultant of this electron gain energy is greater for fluorine. It is same for this here as well. This is smaller, this is larger. So the plus value is here high, plus value here is less. So as a result, this negative value become less, this negative value become greater. Okay, so the highest 4 goes as chlorine, fluorine, sulfur and oxygen. These are, you have to memorize always the increasing order of electron gain energy of top 4 elements. Understood? Alright. Question එකකුත් තියෙනවා කරන්න. Factors that affect electron gain energy. There are 3 subtopics to discuss. Atomic radius, electronic configuration and nuclear charge. Number 1, atomic radius. Let's read. When the radius is small, gained electron is easily attracted by nucleus. Therefore, negative value of electron gain energy, delta EEG, is negative or it increases. Copy that part. If you don't understand, just right away talk to me. Atomic radius, electron configuration, nuclear charge. Alright, moving to the nuclear charge. Next topic, electron configuration. Depending on the present electron configuration, electron gain energy can be either exothermic, that means negative, or endothermic, that is positive. If the element is already having a stable electron configuration, gaining of another electron is difficult. Therefore, process will be endothermic. Delta EEG is positive. During the gaining of electron, energy has to be provided. What are the examples? Elements of group 2, 15, 18 except fluorine. Anka nitharama kiyana except fluorine. For 2024 or 5, I guess, they were given this whole statement as MCQs. Let's read. If the element is not having a stable configuration, gaining of another electron is easy. During the gaining, energy release, therefore the process is exothermic. That's why other than group 2, 15, 18, it's negative values. Alright, now copy this one. Depending on the present electron configuration, electron gain energy can be either exothermic or endothermic. If the element is already having a stable electron configuration, gaining of another electron is difficult. Therefore, process will be endothermic. During the gaining of electron, energy has to be provided. Elements in group 2, 15, 18 except phosphorus. Here. Okay. copy this part and then values of these electron gains. And I guess you guys can do very easily this question number 20. Do the question number 20. Got it? Yeah, you can get the answer only looking at these values. Yeah, but I want you guys to go with this proper understanding. Okay, chlorine, fluorine, oxygen, carbon is way, way less electronegative. That's supposed to have the least value. Okay, see the reasons. Fluorine, chlorine, group 17, I have written by the just a short form, okay, in a nutshell. Carbon group 14, oxygen group 16. Therefore, all electron gain value is supposed to be negative values. So, not 2, 15 or 18. Therefore, energy release when gaining electrons. Radius of chlorine is greater, fluorine is very small. Even though fluorine's electronegativity is higher than chlorine, gaining of an electron decreases its stability due to electron-electron repulsion. Even though its electronegativity is higher than chlorine, gaining of an electron decreases its stability due to electron-electron repulsions. Therefore, fluorine uses some of its release energy during gaining its releasing energy to compensate its instability. Therefore, electron gain energy of chlorine is greater. Same way, electron gain energy of sulfur is greater comparing to oxygen. Also, if you go with the radius of nitrogen and phosphorus, nitrogen needs more energy to compensate its stability compared to phosphorus. So that the electron gain energy of nitrogen is positive, but that of phosphorus is negative. Understood? Okay, complete this part. Nothing to feel? Are F users written at fuses? Change that. F users. F users. And then this part is not there. I know the space actually is not that great here, but I want you guys to copy this little thingy for the sake of final exam. Also, radius of nitrogen is less than phosphorus. Therefore, nitrogen needs more energy to compensate its stability compared to phosphorus. Therefore, electron gain energy of nitrogen is positive and electron gain of phosphorus is negative, even with half half stable electron configuration of phosphorus. Okay, moving on. And then last one is the nuclear charge. When the nuclear charge is greater, electron attracts very easily. So they release energy. Radius and nuclear charge go sort of same. Radius less mean nuclear attraction is greater. And also when the nuclear charge greater mean nuclear attraction is high. So that they are gaining electrons easily, removing energy. Let's read. Higher the nuclear charge, the attraction exerted by nucleus on gained electron is high. Therefore, the negative value of electron gain energy increases. So, electron gain energy is greater. Along a period, what happens? Tell me, along a period, electron gain energy is supposed to be usually highly positive, highly negative. Because by gaining electrons, easily they are reaching inner configuration. Understood? Going down a group, what happened? It's supposed to be other way around. It's more positive. Yeah. Okay. The electron gain energy become less positive across a period, more positive down a group. Okay, complete this. Isn't it relaxing? Each time whenever I'm completing one of these units, I feel really like, wow, little more to go, little more to go. Big more to go for you guys. Alright, see. Before this 2019 new syllabus, they didn't use the word electron gain energy, but they were using electron affinity. Now it's out of syllabus. But this part I adapted from your resource book because they were explaining that. So if they're explaining something, they are allowed to ask questions. So that let's write this little part as well. So the difference with these two, the connection between these two is exactly the same magnitude, same value. But only the sign is different. If we go with this example here, electron gain energy of chlorine is minus 349. Electron affinity of chlorine is plus 449. That is the only difference. That is, sorry, 300. Yeah, just the magnitude is there. Only the sign is different. So that the electron gain energy is related to electron affinity as follows. Electron gain energy delta AEG equals exactly electron affinity EA, but the sign is different. Electron affinity defines as the change of energy when the anion of element loses an electron in the gaseous phase. See, opposite. Cl. So earlier we had chlorine plus electron, Cl minus. Now we have Cl minus become Cl losing its electron. So I have taken a common example here. Electron affinity is equal in magnitude and opposite in sign of the electron gain energy. Therefore, electron affinity become more positive. Electron gain energy, easily they are gaining, become more negative. So electron affinity become more positive across a period and less positive down a group. Understanding? All right, just complete that little part. My choice not right. Yeah. And just this equation inside the square. No, ignore, sorry. This. Done. And then equation here. Down there, the equation. And Martiana Q21. Make it a Q21. Kala neda. Okay, I think now questions to back on it. Because I want you guys to understand this periodic trends nicely. If there are spaces, T1. I want you guys to go to this structured essay. Let's move on to let's start from question number. Yeah. Question number 7. Structured essay question number 7. I know it's really complicating when you are reading the very first time. Your one of your papers are down there. ඇඳලා ගන්න ඉතින්. Education එක තරම් වටින දෙයක් නෙවෙයි. Give it a try. You guys can discuss. Your friends can discuss. But before I read the question. Okay, what are transition elements? Okay, go to periodic table and read that. What is the word? It is there somewhere. Not on the periodic table. From that explanation for the periodic table. The word is somewhere there. Where is it? Explanations about periodic table. Found it. Okay, which block is called? Now go there and check. SPDF. What's the page number? See, page number 76. Page number 76. What is the word? Transition element. What are transition elements? Huh? D block elements. That's F. Seriously? What's the page number then? Found it. What do you call D block elements? Transition element. What is the page number? 75. ලියලා නැද්ද ඔයගොල්ලෝ එහෙම එකක්? ලියලා නැද්ද? ඔකට සමහරක් අය ලියලා සමහරක් අය ලියලා නැහැ. හම්බුණාද? F block is called the inner transition. D block is called the transition. මේක දාගන්න. Now you guys know these are transition elements. Then what's the meaning of non-transition? Not belong to D block. F block is out of the story. So what are these? These elements are coming from what? SOP. SOP. Understood? Okay. That's how you're supposed to think. It doesn't matter. Still the question is difficult. I know these questions are difficult. These questions are difficult. Only reason is you guys don't have the experience. Once you get this one, you would do the next one very, very easily. Alright, let me explain you. Could you be able to find the element? No. Okay, see, the very first one. That's why this is difficult. Okay. So this is the portion they were given. This is the portion they were given. This trend, 5 elements. Lower, higher, lower, higher, higher. Understood? From your own one, from where you can find those? See. Lower, higher, higher. Or otherwise, lower, higher, higher. 2 possibilities are there. So they say oxides of A is acidic. A can be what? The very first one. Either A can be this one or either A can be this one. If this is A, that is group 1. If this is A, that's group 14. Group A, what are the elements? Lithium, sodium, potassium. Can they ever be acidic? Always basic. If anything comes from acidic, that's from group 14. One of the example you know is carbon dioxide. It's acidic. So this is definitely supposed to come in from group 14. Understood? Okay. Just listen. Okay. If the oxide A shows acidic properties, what would be the molecular formula of D when combined with hydrogen? Okay, what is D then? If this is 14, 15, 16, 17. Reactions with fluorine, we don't do much because fluorine is too reactive, explosively reacting, and reactivity is very, very greater. So we are usually going with fluorine. If we go with fluorine, with hydrogen, what is the compound they are making? Yeah, that's HCl. But they don't ask about an element. So they ask about the reaction with hydrogen and D. So what is the compound then? HD. Clear? Listen. Okay. Then give reasons for your answer. According to the given pattern, A can be an element from group 1 or group 14. Group 1 metals are basic. A belongs to group 14. Therefore, D belongs to group 17. And then, which element would show the largest atomic radii out of these? Largest atomic radii goes to which element? A. Why? Along a period, radius decreases. So the very first one is supposed to have the highest. So along a period, radius decreases. So this is A, the highest. Draw the dot cross diagram of A with bromine. What is the compound? A with bromine, what is A? Example, let's say carbon. Let's say you don't know the reaction with bromine, but you know the reaction with chlorine. What is that? What is the compound? Seriously, CCl4. Then what is this one? CBr4. But we don't know what is this element, maybe carbon, maybe silicon, who knows? They were not given such hints. So we had to stuck with whatever the given symbol, that is A. So we cannot write CCl4, we cannot write CBr4, so that we are writing it as ABr4. Then they want you to show you guys this dot cross diagrams. Since we have done this dot cross diagrams very lightly for all of us, so we're going to go like that. Okay, so you are just drawing this middle carbon, then 4 chlorine around, and then to complete these 8 electrons, then anyway, you're going to make 4 bonds, then to complete 8 electrons, may zoom stingy. Let me show you guys that. See, these annotation keys are very, very smaller now. In case if I see other than here, if I touch here, it is saying to stop annotation. That's what's happening here. Anyway, so 1, 2, 3, 4, 5, 6, 7, and so on. Complete the octet. You have to add another 6 lone pairs. But then from here to here, one is dot, the other one is cross. So that if I start, these are dots, and then this next one is a cross coming from A. Understood? So this is supposed to have same crosses. Then always these are dots. These are dots. Are you guys okay there? Alright, I want you guys to do this one with my support, and then next one, and next one, so on by yourself. Because we have another beautiful question, that is question number 9 or 10, I guess. Okay, complete this one. We have time. I want you guys to copy this part first. Let me show you guys nicely. Oh my goodness, this is frustrating. Okay, this is the middle one. This is the middle one. And then you have 2 other trends. The green one and then the blue one. Show all this way. Then it can be either this group 1 or it can be either this group 40. And then show this part as well. Use 3 different colors to make it more convincing. These are the questions coming to your term test, not for final exam. I want you guys to go for maximum marks for term test, okay? Don't worry that, don't think that everybody is taking this lightly. Everybody is taking this really, really seriously. Trust me, there are some students already done their syllabus of your age. Yeah, they start their advanced level journey like 2 years ago. But that's all right. At the end of the day, you need 100 marks, they need 100 marks. Finish? Okay. Copy down rest of the answer. And still, I want you guys to show these stuff as well. On the given question diagram, question graph, show this. And also show this. So now things that you're going to bring to the class is increasing. Yeah, from next week. Next week I'm going to give unit 2. Plus you have to bring every week. When there are like timing, we're going to do like the tube book. So to check answers, then you need notebook as well. So bring everything to the class. Notebook and tube book both. Okay, complete this here. Okay, now do the question number 9. Again the same way. Go through, just draw first this known one, then see how would you go with trends. What can be these points? Got a little idea? What kind of a trends are possible? That's you just need to find out possible trends. What are the possible points? Well done. Yeah, all right. Then fourth ionization energy of boron is greater than the fourth ionization energy of aluminium. Why?
So you can write
Radius.
in the first question, you can write both points.
Yeah.
Either one.
No. Let's go to the question now. Since you guys done that, well done. That is what you're supposed to do. Cool. English one, it's here. See. Okay, so one down, one up, one down, one up. Then this possibility is there. The other one goes down. Or otherwise, one down, one up, one down, one. Sorry, one possibility. I'll show you that same possibility this way, the same, okay? And then the dark blue one, first one, and then the second one, third one is also increasing. First one, second one, third one is also increasing. So that if you go with the green one, that is P. If you go with the red one, blue one, that's R. If you go with the this one, that's P. So what are the groups then? You can write groups then. So if you are going down, it's here or here. Then group 13 or 16. If you go up, it's either here or here. So it's group 15 and 18. You can do more. They were not asking, but you can do more. And then if you go to the question, point A, B in the above diagram, first time. Okay. Identify the point for the first ionization energy of the non-transition element with the atomic number Z equals to 2. So this is the very first one. This is the adjacent second one. This is the adjacent third one. False points are not now they done earlier. Anyway, both are possible. They were not saying there are more than one, but it's possible. Understood? Okay, show it here. ඒක ඉවරයි දැන්. Okay. Monday class it came, I'll do that. I'll ring you later, okay? Bye. Just give it a little try to draw like this one coming down here, these two, and going up, that is these two, this one and this. Finish. Okay. Let's finish from here. Okay, they are asking why radius of fourth ionization energy of boron is greater. Anyway, fourth ionization energy of both these are greater because once you remove first 3 electrons, once you remove first 3 electron, next electron is going with the inner one. But still out of these two, it is way greater for boron because its size is less or attraction. So you're going to write these two configurations. Aluminium has an extra shell. Therefore, radius of aluminium is greater than boron. Therefore, nuclear attraction of electrons in aluminium is greater than for boron. Therefore, less energy needed for aluminium to overcome nuclear attraction. Clear? Copy that. Start from here. This is what they're asking. Okay, let's start from there. I don't need to bring this. I don't want this. I can't have. You guys have to bring like note and two every day. And I want your real true opinion. How you guys would feel once since we done the unit one, how we did the unit one, and how do you guys feeling? Whatever you're feeling, whatever the way you guys are really feeling. Finish. One thing you guys misunderstood because rest of all the other lessons are totally different from unit 1. Unit 1 is the bugging, frustrating, all the gaps are there, differences are there, things are not matching to each other, it doesn't have like good, nice flow. But when we are moving from unit 2 onwards, then you would see like more correlation and those are like so much matching with each other. That's the difference. If you try to live with chemistry, if you understand chemistry as a language, not like a subject, if we know Sinhala language, let's say we know Sinhala, we all know Sinhala. So let's say we know Sinhala. So whatever they say, whatever they do, like even the story or idioms or like even when they are joking, we understand everything. Likewise, if you think about the chemistry as a language, whatever the questions they are asking, what is your marks? 100 marks. Keep it up. Bye then.